Good evening, ma'am. Bagusto Mark Leonard C. from BSME4. So, my answer for number 1, which is to what are the considerations to choose between the right boilers, specifically between fire tubes and water tubes. So, uh, water, first of all, water tube boilers are safer by design and generally considered to last much longer than the fire tube boiler. They are available in much larger sizes and recover faster than fire tube boilers. They can also handle pressures up to 5,000 psig and have the ability to reach very high temperature with the use of superheaters. So, because of their inherent design, fire tube boilers are not suitable for pressure above 350 psig. Also, the steam output is less than the nameplate at actual operating conditions. So, water tube boilers are rated at actual operating conditions. However, from the manufacturing standpoint, fire tube boilers are typically lower in cost than a comparable sized water tube boiler. The fire tube are easier to clean and straight fire tubes are easily replaceable. So, let's not forget that there is a tremendous difference in water volume between a fire tube boiler and a water tube boiler. From a cold start, the fire tube boiler, due to its larger water volume, takes longer to bring up to operating temperature or pressure versus a similar sized water tube boiler. With less water volume, uh, a water tube boiler can follow load swings more precisely and generally has better turndown. However, one advantage that the fire tube boiler does offer is that once it is up to operating pressure, it can handle a sudden upward load surge better because of the large steam disengaging area. But the drawback to this feature is that but the but there is a drawback to this feature because once you drop pressure on the furnace or on the fire tube, it takes longer to catch back. So, if you want a safer design, you will choose water tube. But if you want to uh, choose a much more efficient boiler, you will choose the fire tube boiler. Number 2, which is discuss the working principle of an air compressor and how the air is uh, compressed. A step by step process on how the air is compressed inside the air compressor. So, the air compressor draws in air and creates a vacuum to reduce its volume. The vacuum then pushes the air out of the chamber and into its storage tank. Once the storage tank reaches its maximum air pressure, the compressor turns off. This process is called the duty cycle. So, the compressor will turn back on when the pressure drops below a specific number. First, the crankshaft rod raises the piston in the cylinder and pushes air into the compression chamber, decreasing air volume and increasing the pressure. So here, once the air enters the compression chamber, the volume inside it decreases while the pressure increases. So after this, the piston closes, forcing the compressed air into the storage tank. Then the piston opens again to draw in more air and start the process over again.